This is video on kinematics of particles. This is the first video, and here we are going to deal with straight line motion of a particle. Now we are going to consider four cases. When particle moves along straight line and has a constant acceleration, or has an acceleration which is time dependent, not constant but time dependent, or has acceleration which is displacement dependent, or has acceleration which is velocity dependent. So all these four cases we are going to consider in this video. So let's start with first one, where we have example of constant acceleration, and to demonstrate we have taken this problem. It says in a flood relief area, a helicopter going vertically with a constant velocity u drops first batch of food packets which take 4 seconds to reach the ground. No sooner this batch reaches the ground, second batch of food packets are released, and this batch takes 5 seconds to reach the ground. Question is, from what height was the first batch released, and also determine the velocity with which the helicopter is moving up. So have a look. Let's say helicopter is going up like this, and at height h, it drops the first batch of these food packets, and while this is dropping, helicopter continues going up, and what we find is these packets reach ground in 4 seconds. So for 4 seconds helicopter has moved up. Then moment C, this reaches here, again the packet is dropped. And what is told to us that this packet reaches the ground in 5 seconds. This is the given data. Now how we are going to solve it? See, when it's a constant acceleration, you have our very basic three kinematic equations. V is equal to u plus at, S is equal to ut plus half at square, and V square is equal to u square plus 2s. Out of which we are going to use S is equal to ut plus half at square for this problem. So I apply this equation for height h. H is equal to ut. U is the velocity and t is the time, plus half. Now you see here acceleration is gravitational, which is g, and t square is 16. So I basically applied this equation out here. Minus sign is because see, the particles are going down along the gravity, and the velocity of the helicopter is up, so that's why the minus sign. Now after 5 seconds, what happens? The height achieved is h plus 4u, because see, by the time in this 4 seconds helicopter has gone up by a distance of 4 into u, velocity into time. So total height is h plus 4u, and that will be equal to, again using this equation, ut plus half at square, where t is 5 now, so t square is 25, and with these two we will be able to solve for h and u. You see, you subtract the first one from the second one, and then just simplify it, and you will get your u. And take g as 10, and you will get u as 9, and then put this u in one of the first two equations. We have put it in this one, first equation, and we will get h as 44. So quite simple problem, a case of a straight line motion with constant acceleration. Okay, let's go to the next one, where we have example of time dependent acceleration. So for this purpose we have taken this problem. The acceleration of a particle is defined by a is equal to kt square. K is unknown, and data given is, knowing that v equal to minus 32 meter per second when t is 0, and v is equal to 32 meter per second when t is 4, determine k. That is the first part. Second part is, write the equation of motion, also knowing that at x equal to 0 that x is equal to 0 when t is 4 seconds. So what we do, we write a is equal to kt square. Now we all know that a is nothing but dv by dt, and we integrate it, so we get v kt cube by 3 and plus a constant of integration c. Now this c it is possible to evaluate because of these conditions, you see. So at t equal to 0, v is minus 32. So v, if you put it back here, in v is equal to kt cube upon 3 plus c, we'll get c as minus 32. So we have expression for v, see, t cube minus 32. All right. Now with this we want to go further. And you see for this k, we can easily work out. See, that is one of the questions. At t equal to 4, v is 32. So that gives us value of k, which is 3. That is one of the answer which was required. Another is right equation of motion, means right expression for x. So you already have v is equal to t cube minus 32. So you write it here, write v as dx by dt and integrate it. You will have a constant c1, which is possible to evaluate this because of this condition, x equal to 0, t is equal to 4 seconds. So sorry, when t is equal to 4, x is equal to 0, and you get expression for x. Expression for x, you have to put this boundary condition. You will be able to evaluate c1 as 64, and then you have this expression, which is nothing but the equation of motion for this problem. So here with this problem we have demonstrated example of time dependent acceleration. Now next we are going to demonstrate example of displacement dependent acceleration. So for this purpose we have taken this problem. The acceleration of particle is defined by a is equal to 25 minus 3x square millimeter per second square. The particle starts with no initial velocity at position x equal to 0. And we have to do these three things. Determine the velocity when x is equal to 2 mm, position when velocity is again 0, and position where velocity is maximum. Okay, let's do one by one. We write here a. Now mind you, a is dv by dt, but you can't integrate like this because on this side is dv by dt, this side is x. So all you have to do really in this case is write dv by dt as dv by dx into dx by dt and realize that dx by dt is nothing but v. So it is v dv by dx. Now you can separate the variables. See, you can nicely bring it in integrable form. v dv, take dx this side, 25 minus 3x square dx. And this, both sides you can integrate. You will get v square by 2, 25x minus 3x cube by 3, that is x cube, and plus constant of integration. Now because of this condition x equal to 0, no initial velocity, we can work out c1 and that c1 will work out to 0. And therefore your clear expression for v, you see, without this c1. So now next is very easy, determine velocity when x equal to 2 mm. Simple, you have the expression, put x equal to 2 and you get your v. Third is position where when velocity is again 0. Well, you have the expression for v, put it 0 and you get x as 5. So at x equal to 5, again velocity is 0. At the last one, the position where the velocity is maximum. See where velocity is maximum, where is derivative, that is acceleration is 0. So use this 25 minus 3x square, put it to 0 and work out x, and that will be 2.887. So we have solved for all these three questions. Now we go for example of velocity dependent acceleration. So you have a problem like this. A particle moving in the positive direction has an acceleration of a is equal to 100 minus 4v square meter per second square. Determine the time interval and displacement of a particle when speed changes from 1 to 3. So what you do in this case is write your expression for a, recognize as a dv by dt, and then separate the variables. That is, you bring dv and 100 minus 4v square below on one side and dt on other. And then you integrate both sides, right side from 0 to t and left side from 1 to 3, because you are interested in this range. If you do that, you will get time as 0.0245 seconds. So one part you answered. Determine the time interval. Now for displacement interval, you write dv by dt is 100 minus v square. Recognize that dv by dt is nothing but v dv by dx, and that is equal to 100 minus 4v square. And now separate the variables. So all v's you come on left side, bring on left side, dx on right side. Integrate left side as we did here from 1 to 3 and the dx from 0 to x. You will get x as 0.0506 meters. So we have explained here how to deal with velocity dependent acceleration in case of straight line motion of a particle. Thank you.